lesson, we will explore the fascinating world of stereochemistry. Stereochemistry is all about the 3D arrangement of atoms in molecules and how this spatial arrangement affects their properties and reactions. It is crucial to understand stereochemistry, especially if you are aiming for a career in medicine or pharmacology, where the 3D structure can determine the effectiveness of a drug and indeed its possible side effects. Stereoisomerism is a form of isomerism. It occurs in alkenes. Now this is an alkene. In fact, look, both of them are alkenes. I'm going to use this to show you. The carbon-carbon double bond is restricted. Look, as I try to turn it, rotate it, nothing happens. And that is why alkenes show stereoisomerism, whereas alkanes don't. So this is an alkane. Look, as I rotate the carbon-carbon single bond, focus on the green atom. Can you see? It's right at the bottom. So it doesn't show. Alkanes do not show stereoisomerism because the carbon-carbon single bond is not restricted. So that is trans, like we said earlier, and this is cis because both groups are above, similar groups are above. Now we can also name this in another way. We call it the EZ notation. So say for instance, we have a molecule like this. In this molecule, yes, we do have similar groups there diagonally, but if we want to name by the EZ, we actually look at the mass of the atom that is linked to the carbon atoms bearing the double bond. In this case, let's assume that is bromine and that is iodine. Both of them they have a higher mass than hydrogen. So they are both priority groups over the hydrogen, and therefore we call this an E isomer. All right. Now, if we have that, as you can see here, these two below are both below the plane of the carbon-carbon double bond. They are different, they are not the same. So we can't use the cis strands, but because we have the two priority groups above here, both of them have masses greater than any of these, we call this our Z isomer. The final notation is the CIP. Here we have four completely different groups linked to the carbon atoms bearing the double bond. Again, we use the priority group, which is based again on the masses of the atoms that are directly linked to the carbon atoms bearing the double bond. So suppose we have iodine, bromine, chlorine, and hydrogen. Okay? Iodine and bromine have higher masses than these two, hydrogen and chlorine. And therefore, our priority groups, both of them are above the plane of the paper. This will also be a Z isomer. Now, if we were to change it to this, so we now have hydrogen and chlorine diagonally, both of them lower priority. We have bromine and iodine, higher priority, diagonally away from each other. This will be called an E isomer. Stereochemistry is a complex but incredibly rewarding area of chemistry. Mastering it will deepen your understanding of molecular interactions and prepare you for advanced topics, especially if you're interested in medicinal chemistry and pharmacology. Take your time to understand these concepts, practice them, and soon they will become second nature. I'll see you in the next lesson, where we will delve into empirical formula. See you there.